Welcome to Study Loop.
Okay, so this question we want to see if various functions are onto or not. So first up we have f of n is equal to n minus 1. So this is a onto function because if we set n as m plus 1, where m is an integer, then f of m plus 1 is equal to m plus 1 minus 1, so this is m, and m is your integers. So we can get the set of all integers just by writing n as n plus 1. So therefore, this is an onto function. Now b, f of n is equal to n squared plus 1. So this is pretty clearly not an onto function because you have n squared is greater than or equal to 0. So because you're adding 1 to this, it follows that n squared plus 1, or f of n, is going to be greater than or equal to 1. But your set of integers contains negative numbers. You have 0 or minus 1, 1, minus 2, 2, and so on and so on. As a result, there is no way we can get this 0, minus 1, minus 2, minus 3, and so on and so on and so on. This is not onto. Now C, f of n is equal to n cubed. So this is pretty clearly not an onto function as well, because there is no way to get number 2 from n cubed. So you can try this by n cubed is equal to 2, and then solving for n, you have n is equal to the cube root of 2, but this is not in the integers. So therefore, this is not onto. Now D, f of n is equal to ceiling of n divided by 2. So this is an onto function. So the way we do this is we let n be equal to 2m, where m is your set of integers. Then f of 2m is then ceiling of 2m divided by 2. So this is the ceiling of m. Now recall m is an integer, so ceiling of m is just m. So since m are your integers, then it follows that you can get all the set of integers just using this simple transformation. So therefore, this is onto.